to finish up chapter 2 which is all about functions, we're going to cover inverse functions. So you know that inverse means opposite. So like add and subtractor inverses, multiply and divider inverses. And every function, if it is what we call one-to-one, has an inverse. And we will talk about that as we go. So you can see the objectives there written first. Find the inverse functions informally, and we'll talk about what that means, and then verify two functions are inverse. That's a big piece of this section. Use graphs to determine if they have inverses. That's pretty easy. You use something called the horizontal line test. It's pretty simple. And then other than informally, we will find inverse functions algebraically. Informally is used on more simple functions. The algebra process is used on functions that aren't quite as simple. So definition, we've got kind of all this math talk here, which is important to look at, but I like to kind of summarize it down to the nuts and bolts of what it is. So the inverse function is denoted by this f to the negative 1 power, read f inverse, or f to the negative 1, as long as we know that means inverse. And what it means to be an inverse. The main definition is when you compose a regular function with its inverse and you do the opposite and you take the inverse composed with the regular function, both of those results are what is called the identity function, which is just x. So that's how we will check and make sure that we have inverses, is by using what we learned in the last section, which is composition of those two functions. All right, so here's a more simple example, but it's always nice to start off that way. So if we have f of x equals x plus 4, and we write some ordered pairs, you can see your ordered pairs here. If x is 1, y is 5, and so on. We've got all these x, y values, inputs and outputs. The inverse flip-flops those two, right? They're the opposite. So notice in the first ordered pair, our x and y value are flipped. And then the same thing is true if you look at the next three ordered pairs. And the inverse of that x plus 4 is just the opposite, because we've always used the word inverse for opposites, and it's x minus 4. So the inverse, f to the negative 1 of x, f inverse of x, is x minus 4. So pretty simple. If our original is x plus 4, our inverse is x minus 4. Here's how we check and make sure that those are in fact inverses. And that's right in this section here. So I'm going to zoom in. So when you form the composition of f, which is your original function, with the inverse, f to the negative 1, and then vice versa, you obtain the identity function x. So let's look at that in this example. So I'm just going to rewrite what we had written above. So we said f of x is x plus 4. And f of negative x, or sorry, f to the negative 1 of x, the inverse, was x minus 4. So if we do this composition of those two functions, we take the f function on the outside and we insert the inverse. So we're going to insert this inverse in. So here's what that would look like. We would do f of x minus 4 equals, and remember, we're referencing this f function up here. So these are the same function. And so we would take the x, which is what's inside. So let me try and color code that a little bit nicer here. We're going to take what's here and we're going to substitute in whatever's in parentheses. So instead of this x plus 4, we're going to do x minus 4 and then the plus 4 from that original. Here's where the plus 4 comes from. So here's your two pieces. We did the x minus 4 instead of x, and then we kept that plus 4 the same. Now, if we simplify this, we can get that, equals x minus 4 plus 4. Negative 4 plus 4 is 0, so this is just x, and that's what you want. This is the identity function. Just plain old y equals x. Okay, that's what we want to happen, and that's what will happen if you have inverses. So what if we do the opposite of that? What if we take and we apply? So I'm going to rewrite these again just so I can highlight and reference them. So here's our two functions again, the function and its inverse. This time, we're going to apply the inverse, which is this function, to the f of x function. So that would look like the inverse of x equals, oh, not x, sorry, the inverse of f of x, which is x plus 4, equals, so we're going to substitute in f of x. Instead of x here, we're going to write x plus 4, and then we're going to keep the minus 4 at the end. So here's what that looks like. The x, we're going to replace with x plus 4. We're going to keep the minus 4. So here's where those substitutions went in. So instead of x, we did x plus 4. Instead of, actually not instead of, and then we just rewrote the minus 4 at the end because that did not change. All right, and then if we simplify, we get that it equals, oh, I did that again, equals, and combining like terms here, 4 minus 4 is 0, so it's just x, and that's what we want. We want that to happen in both situations of the composition. So this verifies, yes, these are inverse functions. These are inverses of each other. Okay, so as long as you get your answer is x, that in both situations, you will have inverses. So informally then is just having these more simplistic functions and writing their opposite as their inverse. So for example, in the first one for f of x equals 5x. This is multiplying, right? This is multiplying, which means that my inverse would be dividing. And you can write that two ways. You could write your inverse as x divided by 5, or you more commonly would see that as written 1/5 x. Same thing. So if you're given multiply, the inverse would be divide. If you look at your g of x function, the square root of x, we know to undo a square root, we would square both sides, right? So that's the inverse. So if we have a square root, squared would be our inverse. So our inverse would just be x squared. Now letter H, we have two things going on. So this one is a little bit, I don't want to say more complicated, but you take this division. We have divided by 9. So we have division and we have addition. So we need to do the inverse of both. So we're going to change this x divided by 9 into 9x, right? Change from division to multiply. And then we're going to change the the plus 3 to a minus 3, so to subtraction. So we changed the division to multiplication and the addition to subtraction. All right, letter A, same idea. So a of x, if this is 1/2 x, this is dividing, right? This is division. I know we're multiplying by 1/2. This is the same thing as x divided by 2. So then the inverse of that would be to multiply. So my inverse would be 2x. For letter B, if I have x to the third, this is cubed. The inverse of that is to take the root. So the cubed root would be the inverse. So the cubed root of x would be the inverse function. So we're just thinking opposite on these nice and simple ones. And then letter C here, or the function c of x, is similar to what you see above with h of x, except it's just the opposite. So we're going to take this multiplying and this adding and change it to, so here we have multiplying, or multiplication and addition, and we're going to change it to division and subtraction. So here's what that would look like. We would do x minus 3 and then divided by 2. And notice how the whole thing is divided by 2. That's just a rule for your inverses. There's kind of a complicated explanation to that, but just to keep things simple here, You divide everything by that too, just like up here, everything was divided by 9, but we only multiplied the x by 9 because that division rule for the inverse applies to the x value and not the constant. So that's kind of the simplistic way of describing it. So there are your inverses, just finding them informally with fairly simple functions. So if we do that for number 1, now we're finally to our first formal example. Find the inverse informally and verify. So we'll get a little bit of practice. So we want to do the composition of both to verify. So our informal inverse here then would be f to the negative 1 of x equals, right? If we have multiply, we're going to change that to divide, and then we're going to change the adding to subtracting. So we would do x, we would divide by 4, and then we would subtract that 3 instead of add it. Notice how that 4 is in the denominator of both terms there. So those are the functions that I want to check. So we need to then do our compositions to check. So our verify looks like this. We would do f of the inverse of x. So we would do f of the inverse we said was x minus 3 divided by 4. And our f function comes up here. So we would substitute in what we have inside the parentheses to the x value in our function. So we'd keep the 4. I want to color code this. So we're going to keep the 4 like normal. We're going to substitute in for x, and we're going to substitute in the inverse. And then we're going to have that plus 3 at the end. So this all came from that f of x function. And then if we simplify, here the 4's will cancel each other out because we're multiplying and dividing. So those will cancel. So we'll be left with x minus 3 plus 3. These add up to 0 so that we just get x. And that's what we want. We want that composition to just equal x. Now, if we do the opposite of that, and I'm just going to work down so we can keep everything on our screen here. So now if we do the inverse composed with the original function, that would be using our inverse on the original, which was 4x plus 3. And this time we're substituting it into our inverse. So our inverse, let me write it over here so I can reference it. We said was x minus 3 divided by 4. So we're going to substitute in 4x plus 3 into that 1x spot. Everything else is going to stay the same. So we're going to substitute in, we're going to keep the minus 3, and we're going to keep the divided by 4. We're going to substitute in the 4x plus 3, and then simplify. So if we simplify this, we end up with 4x plus 3 minus 3 in the numerator, all divided by 4. Here our 3's add up to 0, so we get 4x divided by 4. 4 divided by 4 is 1, and there's our x. So showing your work to show this is your verify. Okay? So when it asks to verify, showing your work of these two processes and ending up with x for each, that is your verify.